The next topic in our syllabus is about multi-user systems. 4.3. 4.1 was the first part of your fourth module was about diversity techniques, different diversity patterns, transmitter diversity, receiver diversity, and so on. 4.2 we have dealt with what is equalization, why do we want equalization, and what are the different algorithms and steps that we are using in order to equalize a system, in order to remove the inter-symbol interference in a received signal. The next and the most important topic is about multi-user system. We have to understand the different directions, that is uplink and downlink, multiple access systems, FDMA, TDMA, OFDMA and CDMA in our syllabus. Okay, so today we will be covering only uplink and downlink and the introduction to multiple access. After FDMA, TDMA, we have what is called as code division multiple access, CDMA, and another one very important latest technology called as orthogonal frequency division multiple access, OFDMA. So introduction to what is multi-access system. Multiple access means you are having a single set of resource and this resource is accessed by multiple users. Okay, so we are finding out different technologies or different techniques to optimize the use of our bandwidth. One of the most important resources what we have is the bandwidth. Okay, so multiple access schemes, many mobile users share a system resource simultaneously among a finite amount of radio spectrum. The sharing of spectrum achieves high capacity by simultaneously allocating available bandwidth or the available number of channels to multiple users. Okay, this means that we have a limited spectrum. We are going to divide this limited spectrum or this limited resource into multiple users. We are going to develop different technologies to divide the same amount of bandwidth to different users. So for high quality communication systems, this must be done without the degradation of its performance. Okay. In multi-user systems, we are sharing the allocated radio spectrum into multiple number of users. It has become inevitable nowadays because of the requirement of heavy bandwidth, right? More and more we have to increase the capacity, right? A capacity of a communication system depends upon how many number of users can be connected to a particular system at one particular point of time. Okay, that is why we have different multiple access technologies. So we have two important directions called as uplink and downlink. Okay, we call it as forward and reverse also in other terms. In downlink, what happens is that it is a transmission from a base station to the users. There is one transmitter and multiple receivers. It is called as broadcasting or something like that. When there is one speaker and so many listeners, we call it as downlink. It is going from the transmitter base station to different users. You can have an analogy of your mobile phones. There are so many mobile phone users getting connected to a single mobile tower or a single base station. This process is known as downlink. Uplink is the other way around. Different mobiles are getting connected towards a single transmitter. When one A, B, C, so many people from our class, each one of you are calling to a particular station. So there are so many signals that is being received at the transmitter end or the base station end. These are the two important directions. We'll see what are the differences and we'll compare what it is as we go on in the coming slides. So the transmission direction can be of two types, can be the uplink channel or the reverse channel, and downlink channel or the forward channel. In some textbooks, the word or the words that is used is, instead of uplink, they have used it as reverse channel, and in other certain things for the downlink, it is the forward channel. Either way you can mention. Suppose you get a question based on forward channel, don't get confused what it is. What is an uplink channel? An uplink channel, otherwise known as reverse channel, is a multiple access channel that has many transmitters sending signals to one receiver when each signal must be within the total system bandwidth. We call it as B. In an uplink, each user has an individual power constraint associated with its transmitted signal. So here, individual users are calling directly to the base station. Suppose we have multiple users. Imagine that 1, 2, 3, 4, 5, 6, 7, 7 of you are contacting or are trying to dial to a dialing some number. All these mobile phones are getting connected directly to one base station. So we have individual power constraints in each of these users. So each user will have its own power. Okay, that is what is mentioned here. Signals are sent from different transmitters and is received at a single end. Okay, but the bandwidth is as usual divided among all the users. Okay, so this is called as uplink channel. Shall we draw the block diagram of uplink channel? Have you? So we'll see some examples, like say wireless uplinks, laptop, wireless LAN cards transmitting to a wireless access point. Suppose we have a one example I told you, no, we have already seen the example mobile phone. Similarly, you have another example when all of you are getting connected to a wireless access point within our campus. We have Wi-Fi facilities here, wherein when you make a connection to your Wi-Fi, all these are getting connected to a single system, right? This is called as an uplink. This is a basic block diagram of an uplink channel. You have multiple users here, each, say for example, user 1, user 2, user 3, each transmitting a signal with a signal S1 of t, S2 of t, S3 of t, and so on, is traveling through a wireless channel with a frequency response given as H1. Finally, there is a noise added, and this is being received at the receiver end with an antenna. This is the fundamental block diagram of an uplink channel. This is a fundamental block diagram of an uplink channel or an uplink. Next, we'll see what is a downlink channel. Is a broadcast, or called as other words, a forward channel, and has one transmitter and many receivers. As we have seen now, let this be a base station here for a mobile communication system. Let this be the transmitting antennas. We have multiple amount of receivers here. When there is a transmission from this to this, make sure these arrows are very important, because we are starting from the transmitter and we are reaching the receiver here. This is called as downlink. Now, I would like to remind you about what is called as duplexing. We have discussed about duplexing in the previous semester. Full duplex and half duplex. When a transmission channel is capable of sending and receiving a signal at the same time, we call it as full duplex. If we cannot transmit or we cannot receive at the same time, we call it as half duplex. This is called as duplexing. In duplexing, you have two different types of duplexing called as frequency division duplexing and time division duplexing. In frequency division duplexing means you are dividing the channel according to the frequencies. That means that there is a possibility of receiving a signal and transmitting the signal simultaneously at the same point of time. This is called as full duplex. For half duplex, you might have seen the wireless telephones that is being used by wireless systems used by the police department and others. When one person says over and stops, only then the next person starts speaking. This is a half duplex system because at one particular point of time, it is only possible to either transmit or receive. Okay, that is called as duplexing. Here, this comes relevant when we go on and when we try to understand the coming multiple access topics. In downlink channel, what happens is that there is a single system transmitting signals to different users. It's called as broadcasting. You can think of FM radios or televisions as an example of a downlink transmission system. So here we are going to consider that there are, we consider about K users, and a signal S of T is transmitted through the downlink channel with power P and bandwidth B. The S of T, the total signal, is nothing but the summation of all the individual signals. It is getting spread. See here, S1, S2, and so on up to Sk of T. The all together transmitted signal is called as S of T. So this is a basic block diagram of a downlink channel. Here we have a transmitting antenna, S of T, transmitting in different directions. This we'll call it as S1 of T. And what we receive here is S1 of T plus N1 of T. Okay, it is an additive white Gaussian noise. So this signal is being transmitted through a channel with a frequency response H1 of T and received towards the users 1, 2 and 3. This is a simple block diagram of a downlink channel or a transmission from a single transmitter to multiple receivers. So as shown in the block diagram, the downlink channel, all signals originate from a single transmitter. We call this as S of T. Okay, this signal is being split into, say for example, for K users, K, we get Sk of T, where what happens is that originates from the same transmitter and reach different destinations or reach different receivers. Now this would help us in synchronization because it happens from one end. So synchronization is comparatively easier to the uplink channel. When you compare uplink and downlink, it is more easy to synchronize a downlink channel because the energy is known, the signal is known, and it is divided into equal number of users. So both the signal and interference are distorted by the same channel. For downlink channel, we have examples like radio and television broadcasting and so on. Compare and contrast the uplink and downlink channels with relevant examples. If a question arises in your exams, you should be able to answer it. So these are the slides that help you to answer these questions. So as I told you, you may get questions about comparison between uplink and downlink. So these are some of the important points that might help you to answer your questions in the examination. What are the differences between uplink and downlink? What are the things that we have to consider when we design an uplink channel and when we design a downlink channel? The fundamental difference between the uplink and the downlink channel is that the different users are distorted by different channels. In the case of uplink, downlink signal and interference are distorted by the same channel. In uplink, each user has individual power constraint associated with its transmission signal. Downlink, no, you are dividing it, right? In uplink, each user will have his own power limitations. Downlink, you have the power in total and you are getting it divided among the different users. These are two important differences. There are n number of other differences. You can go through the references and find out and make it as points, and depending upon the number of marks the questions is asked, you can write it down. So two important points that differentiate or that technically compares both the uplink and downlink channels. We have a bandwidth division. That's why we use this for multiple users. You need to understand this, because only if you understand this you will be able to understand the upcoming sessions on frequency division multiple access, time division multiple access, code division multiple access, and a very important and novel technology called as orthogonal division multiple access. If you have to understand all these technologies, you might need to know very well, very clear with the uplink channels and downlink channels and how the frequencies are allocated within these particular channels and how this communication happens without any hindrance or without any kind of disturbance. So what is really meant by multiple access and multiple access technologies? Multiple access techniques divide the total signaling dimensions into different channels and then assign these channels to a different users. So we have a set of, what is a channel? Channel is nothing but a band of frequencies which is allocated to a particular user. In wireless communication, this is what we can imagine. So we need different methods through which we allocate a particular channel to a particular user. So there are different n number of users and we need different mechanisms to allocate a particular channel to a particular user. This process is called as multiple access. A mechanism for multiple users to access a common radio channel. That is what is multiple access technologies. We have another kind of technology which we'll be seeing, which is the exact contrast of multiple access technology. And one of the reasons why we have a huge amount of data rate and high capacity systems in 3G and 4G mobile communication is because we started using multiple access technologies. The allocation of available bandwidth into different users in wireless communication is known as multiple access. What do you mean by multiple access, and what are the different technologies that is being used in allocating the resources among different users? In this we'll be studying four important techniques. The four major techniques are FDMA, TDMA, CDMA and OFDMA. The four major multiple access techniques are frequency division multiple access, time division multiple access, code division multiple access and orthogonal frequency division multiple access. There are two types of multiple access technologies based upon the band. If it is converted into narrow bands, we call it as a narrow band multiple access, and if it is larger than the coherence bandwidth of the channel, when frequency selective fading occurs, we call it as wideband systems. So we have two types of multiple access systems. One is narrowband and the other one is wideband. So I told you that multiple access technologies are very important. We have something called as radio access networks RAN in our 5G communication. So we have two types. One is called as multiple access and the other one is medium access. And FDMA, TDMA and OFDMA are classified as orthogonal multiple access systems. Okay, we have another one, CDMA. We'll see it in the next slide what is meant by or why, what is the other type of multiple access system. These are all orthogonal systems, but code division multiple access can be orthogonal or non-orthogonal depending upon the coding that you are going to apply with. Okay. CDMA can either be orthogonal or non-orthogonal depending upon what type of coding you are going to do. So we have spread spectrum multiple access systems other than the orthogonal. Spread spectrum, as I already told you, could be orthogonal or non-orthogonal. So we have an important system called as code division multiple access. In that we have two different systems. One is called as frequency hopping FH system and the other one is the direct sequence system. So with this we have completed the first two topics in the third part or the final part of the fourth module 4.3, where we are asked to learn about uplink, downlink and an intro to multiple access. Multiple access. In your syllabus, in the fourth module, we have frequency division multiple access FDMA, TDMA, CDMA and OFDMA remaining. The rest of all these things are completed, and once we start that, it is going to be very simple and very easily understood. So, are there any queries related to multiple access, uplink, downlink and so on? Any doubts or any queries? So in the next session, once we start with this, we can finish the entire multiple access schemes, that is FDMA, TDMA, OFDMA and CDMA most probably in one session if possible. If we could finish that, and it requires a sufficient amount of time, which we'll do it in the next session. So thank you all. Thank you very much for listening to me.